The next step is to write the equations to describe this circuit. Now, there are 5 currents that we need to find. And with 5 currents, that means we have 5 variables. And this means that we need 5 equations to solve for those 5 currents. Well, we have 2 nodes. We have V3 and V4. So we're going to have 2 Kirchhoff's current law equations. And then that just means we need 3 Kirchhoff's voltage law equations. And we'll have all of the equations that we need. So let's look at V3. I have I5 going in, and I4 going in, and I3 going out. So what's positive is what's going in, negative is what's going out. So I'm going to have I5 plus I4 minus I3 equals 0. And this is our node V3. At V4, we have all the currents going in. So we have I1 plus I2 plus I3 equals 0. And that's at node V3. Now, let's not have a problem here with all of our currents being positive going in. That just means that one of these currents or 2 of these currents are going to be negative. And a negative current just means we chose the wrong direction. We just need to flip it. Now, you don't have to go through and correct everything so that all the currents are positive and you're flipping arrows. I can understand and read and check your problem. As long as I see the arrow and I see a negative number, then I know, well, that just flips and we're good. Now I have Kirchhoff's equations. Now I have a bunch of different possibilities for loops, but I'm just going to have loop 1, loop 2, and loop 3. So for loop 1, we start at ground. It's just a good place to start, and I'm going to go around the loop checking my polarities. So as I start over here at ground and I work my way over to my potential, I'm going to take the sign on the other side of the component. So I'm basically jump over, take that sign. So I'm going to have plus V1, and keep going through, and I hit this resistor R1, and I'm going to jump over and take this sign. So I'm going to have minus, and it's going to be voltage of R1, and keep going around, and I get to R4. I'm going to jump over and I'm going to take the sign plus VR4, and that's equal to 0. Now I can rewrite this in terms of current and resistance. I'm going to have V1 minus I1R1 plus I2 times R4. And that's going to equal 0. Now we have loop 2. And here, start at ground. I'm going to go around, jump over to the other side for the first component R4. I'm going to have a minus VR4, jump or go around this loop, jump over R2. I'm going to take plus VR2 and continue around my loop, and I get to R5. I'm going to jump across, take the sign, which is a positive, and that's going to be VR5, and that's going to equal 0. So now I have, changing this into currents and resistors, minus I2 R4 plus I3 R2 and plus I4 times R5 equal to 0. And for my last loop, L3, again, start at my ground. I'm going to go up, jump over R5, and I get to the negative sign, negative VR5, go around my loop, and I'm going to jump over R3, get to the plus sign, plus VR3, go around, I get to V2, I'm going to jump over and say minus VR2, and that gets me back to my ground, so that's going to be equal to 0. And changing this into currents and resistances, minus I4 R5 plus I5 R3 minus, it shouldn't be VR2, it should just be V2, sorry about that. Got so used to writing R's. Minus V2 equals 0. And now I have 5 equations and 5 unknowns, and I just need to solve those. You can use whatever method you like to use. One interesting one on the some of the calculators is the TI calculators is what's called RREF, reduced row echelon form, and that will solve it pretty well. Of course, you can always use Cramer's rule. However you'd like to solve them, it's up to you. I don't have a particular way that you need to do it. You can go old school and do substitution. If you really want to and have fun, you can do elimination. However you like to do it, but I leave that up to you. Now, once you solve the currents in this form, I get I1 is equal to 0.238 amps. I2 is equal to negative 0.121. I3 is equal to negative 0.117 amps. I4 is equal to negative 0.123 amps, and I5 is equal to 5.594 milliamps. So this is how you solve the circuit.